Hi, I'm Chris. I work at IBM as a site reliability engineer. And I'm here today to talk to you about how to be productive in a terminal environment. So I'm going to share a bunch of tips and tricks that I've learned over the last few years that I feel like have made an enormous difference in my ability to get things done. I think they're relevant to you if you ever touch a terminal. You don't need to be an SRE, you don't need to be in DevOps, whatever that is. If you enter a terminal at some point in your workflow, I hope this will help. So let's get started. An outline of what we're going to look at today, I need to give you some disclaimers to protect you and me a little. I want to talk about the guiding principle that I use to choose tools that I hope might be a helpful heuristic for you. And then I want to give you a bajillion demos, probably so many demos that we'll run out of time, and yeah, we'll just see how far we get. So those disclaimers. First, I'm going to show you a bunch of cool interactive tools, and by virtue of being interactive, some of them don't make any sense for scripting. I'm not telling you to put them in production. If you choose to do that, some of them that might even make sense, but that's your decision. Don't say that I told you to do that. You should also not assume that these things are available for portable shell scripts. And by portable, I mean it's intended to run on someone else's computer ever. So don't do that either. This is not an exhaustive list. I'm going to show you a bunch of stuff. Many of them have tools that accomplish a similar goal in a different way. Sometimes I'm going to present the one I learned the first. Sometimes I'm going to present the one I like the best. Sometimes I don't know that there are other tools that might even be cooler and better. So I am still learning, and I would really love for you to use my contact information on the last slide to tell me all about the stuff I didn't talk about. So let's get going. The philosophy of how to choose tools. People use a lot of different metrics to decide what makes a tool good. Is the tool fast? Is it easy to understand? Is its job simple and focused, a good Unix single responsibility? Is it well documented? Is it huge? Is it bloated? Does it have features I don't need? Is it portable? Can I SCP it to a server and expect it to run over there no problem? Is it powerful? Is it flexible? Is it Emacs? And these are good metrics. I'm not trying to say that they're not, but I think I decided they're not the most important metric for me, and that's feedback. I think that your ability to get stuff done, get the stuff you want to get done quickly, comes down to how quickly your tools give you feedback, how quickly they deliver answers to you, and how well they guide you as you are using them. The whole point of agile software development was, okay, let's stop delivering enormous units of functionality only to find out that they're not what the customer wanted in the first place. Instead, let's take small but usable on their own slices of functionality and hand those to the customer and figure out, oh wait, we're doing the wrong thing, and course correct as early as we can. And that's the same experience that I think is important to being productive in a terminal. Getting that rich feedback as quickly as you can. And so I try to find tools that can do that. All right, let's look at some tools. I want to start with a story, and I think it's a story that might be familiar to many of you. You're in your home directory in a terminal, and you need to go somewhere. That somewhere is like 8 directories deep. You know that it's in documents, so you type cd, doc, and then you hit tab because you're advanced. You know how to use the tab completion. And it writes the word documents for you, and that's great. And then you can't actually remember the name of the next directory, so you hit tab twice, and your shell lists all those directories, and then you type the first 3 letters, the next one, you hit tab, and then you type the first 3 letters, the next one, you hit tab, and then you do that again, and again. And every level you've forgotten the names, you double tab to get the list again. And eventually you construct a relative path where you wanted to go. and you hit enter, and you're finally there. But then you need to go somewhere else. And that somewhere else isn't just a subdirectory of the current one or like a few levels up. It's, in a sibling hierarchy. And you've got that dilemma. All right, so I could write CD again, but do I start from the root of the file system, or do I try to remember how many levels up it is and ... that many times? It can be a pain getting around. And even once you've gotten where you need to go, it's still a pain to go anywhere else. And I can mostly make that go away. So, Z. Z is a brilliant shell script that most people in this room could have written, but we didn't think of it. I wish I had. But there's implementations for fish, bash, and ZSH. It's 100% shell script, and it adds a tiny little hook into your shell whenever the current working directory changes. And all that does is record where you went and when you went there. So it builds this tiny little database of an absolute path, the number of times you've been there since you installed Z, and the last time you were there. And then if you want to go anywhere, you type Z space, and then some little substring of the path you want to go to. And that is a little bit like in your browser, typing the first few letters of a website you visit frequently and hitting enter, and bam, you're there, right? We've all, I think, grown to rely on that behavior. And it's the same thing, but in your terminal. Let's look at it. So I'm in my shell, and I can type Z, and I am at the presentation source code, the source code of the presentation I'm giving right now. Or I can type Z and go to my local checkout of Linus's kernel tree. Or I can type Z, look how far away we are. This is where we can check whether my system is vulnerable to speculative execution vulnerabilities. So Z lets us jump around all over the place on the file system easily. Now you have to go there once, right? It has to learn in order for you to be able to do this. But once you've been somewhere once, you can get there again. Now, sometimes multiple directories contain a substring. So to handle that case, it has tab completion. So we can say, hey, here's the substring I want to go to, but I'm not sure you'll take me to the right place. Hit tab and see, here are things that Z knows about that match that substring, and then we can choose. It's still faster than constructing the path. So that database that it's using to store this stuff, if you're in bash or ZSH, this is going to be in a different place, but it's the same thing. It looks like this. So it's an absolute path, a pipe, the number of times you've been there since you installed Z, a pipe, and the Unix timestamp the last time you were there. It's that simple. I couldn't believe how much of an impact this had on my productivity while being painfully easy to build. So I hope it helps you too. Now, getting around is only one of very many things that we have to do in the shell. We got to find things, and sometimes we got to find things before we can even go to them, right? We don't know where we put that one file 4 months ago, and we need to hunt it down. And there's a bunch of really great tools out there for doing that. You're probably familiar with find and grep and maybe locate, but there are new, shiny, rich feedback tools for this task. So we're going to start with a strange one. FZF stands for fuzzy find. It's in Go, and let me qualify fuzziness because that's a really important characteristic of what makes FZF a powerful tool. Most other search utilities, you can either search for a literal substring or you can search for a regular expression. And I think we can agree that even if you're good at regular expressions, it takes time and energy to construct the right one. It's easy to make it overly general and match everything, even stuff you don't want, or overly specific and match nothing. fuzziness in FZF's view of the world is I can provide a string, and it will search for the letters I provided in that string in the order in which I provided them, but with anything at all in between. And that ends up being exactly the right amount of fuzzy for most of what I need. It lets you search for, hey, I know this thing contains 2 words, but I don't think they're next to each other, right? So let me just search for those 2 words, and I can actually get the thing I want. It uses a number of other clever heuristics too. So let's take a look at how it can be used. So for starters, if you're on Linux, dmessage just dumps the entire kernel ring buffer of logs since your computer booted. And that's just a convenient way for me to get some logs that we can search. So FZF listens on standard in, and it gives you an interactive interface for filtering and sifting through standard in. So let's look for the string error. You can see here it has found a number of different errors. But I want you to notice the case in these errors. This one is uppercase. These are lowercase. This one is mixed case. FZF uses smart case, which means if you didn't specify a case in your input, it'll be case insensitive. So if we use the default lowercase, it'll still find uppercase stuff. But the moment we start to be specific, if we use a capital letter, it's going to search case sensitively. So I can show you that if I can type, way fewer results. You can control this behavior with flags if you really need that like strict lowercase stuff, but I find that this is what I want most of the time. We can also see that fuzziness in action up here on this line. You can see that recovery has an ER, and then required has an R, O is in on, and R is in read only. So that's the fuzzy heuristic at work. And in this case, of course, that's not a very useful match to me. But sometimes it really, really is. If I want to search for like the Intel graphics driver that my machine is using, and then, I don't know, log lines related to VGA output, they exist, at least one. And FZF emits whatever you select on standard out. And that ends up being really cool because you can use it for everything. And I mean everything. So think about, you're trying to recall the, what am I doing wrong here? Live demos, how great they are. I can't type or something. Derailed. Is it all broke? No? Okay, well we can do that. So if you want to use it to find a specific file, you can search all of the files and folders underneath the current working directory by their name in FZF. So if I'm interested in editing some main.go somewhere, and there's a whole lot I could choose from, FZF can be the thing that shows me the candidates, and I can use it to quickly drill into what I actually care about editing, right? And we can be even more specific. If I can remember the name of a package that a file is in, I don't have to construct this long path to get to it. FZF can also be used for changing directories. So if you need to go somewhere for the first time, you can integrate the FZF capabilities into your shell. And for me, it's Alt-C. I don't know what it might be for you. And if we wanted to go to this Mint folder, we're here. So bam, that's a faster way to go somewhere for the first time. And once you've been somewhere for the first time, you never need to type the CD command again. So you're done. CD is gone. You don't need it anymore. I still use it sometimes for like this stuff, but whatever. No one's perfect. So let's go to a Git repo that I work in frequently so I can demo a few other cool things. FCF can be used extensively in shell scripting. So here is a function originally written by my tech lead, Josh, but I rewrote it because I didn't have a copy locally yesterday. So this is a git checkout command that lets me use FCF to choose which branch to check out. Now FCF has a preview functionality where it can run some arbitrary shell command to visualize the content of a choice for you. So over here on the right, it's visualizing the head commit on this benchmark branch. So I can see the commit message, and I can see part of the diff, and that's scrollable. And so if we actually want it to be on master, we can see that's a boring merge commit with nothing in it. And I can't check out because, you know, fixed it. I didn't need that. So you can use FCF really easily to do things like that. That was a really easy shell script to write. I had git list all the heads of all my branches, and then I removed part of their name that was verbose beyond my needs. And then I told FCF, hey, so on standard in, you're going to get a SHA commit and the name of branch. They're separated by spaces. So I only want you to show me the name of the branch. I want you to show me the second space delimited thing, but preview it by running git show on the first space delimited thing. It was that easy. And then, you know, when we do that, we just check out the branch. Done. Okay. So I use it for searching my history as well, but I'm pressing Ctrl+R and nothing is happening, so we're just going to move on. But you can use it in place of your shell's reverse index search or the painful up arrow process, and it is so much better. I'm very disappointed I can't show you right now. Okay, so that's fuzzy find. You can use it like find to find files. You can use it like grep to search within files. And you can use it to make decisions, like which branch do I want to check out. And I think you'll find that if you think, you can use it for almost every decision you have to make in the shell. And it's a really great interface for doing that, because you can choose from among a lot of options really quickly. But sometimes you do need find. Sometimes you need to search millions of files, or your entire file system for that thing that you wrote in some directory that you can't remember a long time ago. And that's where I would recommend FD. So FD does most of the same things that find does, but it applies a bunch of heuristics to those operations that I think make it significantly easier to use, more intuitive, and give you better feedback. So it is also faster than find, even if you turn all the heuristics off, like 9 times faster. So you can really feel that on most systems. And if you want to see the benchmarks, they're all in the README of their Git repo, so go check that out. I don't have time to show those off.
Does that require an index?
Nope.
Pass-through?
Nope. It's just like normal find, but highly parallel. So let's go home. Actually, we could try. So uinput is a user space input driver as part of the Linux kernel. And we could search, my entire hard drive for matches to that in a sane amount of time. The reason that took a sane amount of time is because of the heuristics that FD applies. It skips hidden files and folders by default. This means that it's not going to descend into your .git folder in every repository on your file system. It's not going to read your browser's cache. It's going to skip a whole bunch of stuff that you almost certainly weren't trying to search. Of course, this is tunable by flag, but I think it's a really great default. It also reads gitignore files and the equivalent for most version control systems. It assumes, well, you're probably looking for code, not output artifacts. You can turn that off too, but that means that huge portions of the small files on your disk get to be ignored. And that also ends up being right most of the time for me. So it uses smart case the same way that, actually first I should compare, right? So if we wanted to do the same find, we would do find u input, and I suppose case didn't matter in this instance. Have I done something wrong? Oh yes, I have. You see, find wants me to tell it, yeah. Find wants me to tell it that I'm looking for the name of a thing. FD thinks that's probably what I was going to do. Of course, we can do other things with FD. There's flags. But FD does the thing I wanted 80% of the time without flags. And that helps. That smooths the way. Its output is colored by default. It's targeted at you, the human, trying to find a thing. But you can use it in a script, and it's going to be faster, too. So I recommend you investigate that. Now, if we're in my home directory, and we look for Arbor, which is the name of an open source project I work on, we can find a whole bunch of matches throughout my home directory. But if we look for Arbor, we'll only find one, smart case again. So that regular expression is going to be case insensitive. And yes, it is a regular expression. We still have that. I usually don't need it with what I do with find. But this allows you to have that same, like, by default, I don't need to worry about case. But when I care, it is easy to make the tool care. So find's equivalent would, of course, be I feel that one of these is a lot, easier to manage and type. Okay. Moving right along. ripgrep. So you may have heard of ripgrep. I know it is relatively well known, especially among people who use Rust. But it's not just faster grep. I mean, that is accurate. It tends to be about 4 times faster than GNU's grep implementation. But again, benchmarks are on their GitHub. But it applies these same heuristics. And that ends up helping me a lot when I'm looking for things. So, whoops. It recursively searches your file system by default if you don't provide it something to search on standard in or as a file name as a command line argument. So if you're in a file hierarchy and you're looking for the file that contains whatever word, it is very easy to do that search. You can just do things like rg uinputs, right? And you'll notice the default output format, I think, is very friendly. It's the relative path to the file that contained the match, and then each match on its own line with its line number. Now, of course, grep can output like this, totally. There are, I think, 4 flags needed to get this output format in grep. And I enjoy not needing them every time. I also enjoy how fast it is to do this search. If we're going to attempt the same thing using GNU grep, it would be just this, I think. I'm actually going to have to kill this prematurely because it's searching everything, right? There's not an easy way to tell grep, hey, don't go into hidden files. Hey, get ignored things. This has to search a lot more stuff. So I think that was about the same amount of time I ran ripgrep, except I got answers with ripgrep. I got feedback a lot faster, and that is useful to me. You can also have ripgrep do some interesting stuff. It can output its matches in JSON if you want to do some really fancy scripting. We don't have time to really explore all of the ramifications of that, but there are cool possibilities here when you can get structured data out. Also, recently, I'm gonna jump over to a repo. I had occasion to write this rg-ed function, which uses ripgrep to search for matches in files to some regular expression, and then it uses fzf to let me choose which of those matches is interesting to me and open it in a file. So if we were to search this Go code for the keyword const, there's going to be a lot of matches, but you can see again we're taking advantage of FZF's preview mode, so we can see where these constants are, and then we choose one, and we're in that file. Now, I couldn't generically jump to the line number it was, because editors don't have a consistent syntax for that. But I intend to implement it for my editor, which we'll talk about later. Okay, that's ripgrep. Gron. Gron is weird. But I think you'll find that you probably have needed it. And in the future, when you encounter this problem again, I hope you remember. Gron is all about JSON. So let's look at some JSON. Earlier today, I used the GitHub API to pull this big old JSON description of a pull request that I made. I did that because of rate limits. The last thing I wanted was live demo, oh wait, you've exceeded your quota, go generate a personal access token. So here we have a beautiful JSON object, right? I think a lot of us end up working with APIs at different points, and sometimes you have to do that from a shell script. And you have to work with JSON, and so we get really familiar with JQ, right? JQ, I mean, it pre-prints JSON, but that's like the least of its powers. It also lets you query for things, right? So JQ.comments, I think that comments is at the root level. So you can see that we've just used it to pull out this information from the JSON object. And that's great, except what if this JSON object is like 15 nested objects? And I'm scrolling through trying to look at it, and it's like, okay, so where is this in the overall hierarchy? What's the query string? I know that the last thing's going to be key, and then license, but what is this inside of? And I have to scroll up until I find the beginning of that object, and I hope I don't miss it, right? How do you find specific data's location within this overall structure efficiently? Because even if you use our wonderful tools, if we're looking for key, did I misremember its name?
You have JQ in there still.
That would just, oh, I'm filtering it with JQ, you're right. So even if I'm looking for key, I can see, yeah, it's indented, right? I can count the indentation to infer how many layers deep it is, but how do I know where it was? That's where Gron comes in. Gron is a thing of great beauty. Brace yourself. Gron converts JSON into equivalent JavaScript that builds the object. So every line of this tells you the data and where it was in the hierarchy of the object. Gron can also convert from this format back to JSON. But what that enables you to do is use other tools to search for things within that JSON and understand where they came from, right? So we can see that this key, is in base repo license key, and then we can steal like from right here, and that's valid JQ. He thought.
You're groning. You need to catch.
Oh, I am groning. Thank you. I don't know what I would do without great people.
You would skip demos.
I would skip demos. There, see? It is valid JQ, I promised. All right, so if you've ever had this problem, I think Gron is indispensable. And if you haven't, I hope you remember when it happens. Gron lets you search JSON in a line-oriented way, and it has saved me a lot of time. It also combines really well with YAML to JSON, TOML to JSON, and their friends. If you can make it JSON, you can understand its structure with Gron. Okay. Next category. Looking at things, right? So we can move around, we can find stuff, but viewing things is still an important part of the shell experience. How do you understand the files and folders that exist on your system? And the first way we do that, I think a lot of us use ls. You know, what is here? It's an important question. And exa just eclipses ls for me on like every axis. It's in Rust. It's about as fast. I aliased it to ls, so I've been using it this whole time. And its output format is just so rich. Let me show you. So exa color codes the permission bits so that the differences stand out. It uses human readable file sizes by default. If the owning group and user are the same, it will only show up once. It can understand Git. So you can see here that these files have been changed, like the M is modified and the N is not added to version control. So you can confirm that with Git status. And then I used to be a really heavy user of tree. I love this. I think this is a really easy way to understand how things are structured. But this is a clearly better way to understand everything at a glance. There is just more information here. So now I don't use tree anymore. I'll miss it. It'll always have a special place in my heart. But it is gone. And I should have demoed at the very top here. That was probably
Keep the tree off.
Foolish. H instead of human readable is give me column headers so that I know what these things mean. It has a bunch of other flags. They're not the same as the ls flags, but they're useful, and I would encourage you to explore them. All right.
So based on the directory that you're in, the column headers will change automatically, pretty much.
Well, the format is not going to vary very much.
But if you're not in a Git repo, it's not going to show you the Git header or anything like that.
Yeah. So bat. When I first saw bat, I thought it was useless. So its use is subtle. Bear with me. Bat is cat, but with some extras. So if we were to go to some, source code and bat it comes out on standard out, but with a file name heading, syntax highlighting, and line numbers. Now, since there's an entire website dedicated to how cat minus v is the worst idea ever, because that's not cat's job, I was really skeptical of that at first, before I found its niche. But that has actually been really valuable to me because of situations like this. So if we were to open an editor and then use FCF to choose which file to open, because that's a thing we can do, and we were to look at, this test file, you see this preview here on the right. It's syntax highlighted. Now, how do you get a syntax highlighted version of a file with a single shell command? You use bat. You need some file or some command that can render this information for you in a standalone way. And there are a few others, but you can use bat for this. If you recall my RGEd, this is also bat here on the right. And you can see that it's highlighting in the file the line that contained the match to my search. That's another thing that bat can do. So I think bat by itself It's a great way to view a file, I guess. It gives you that syntax highlighting. It automatically invokes a pager if the file's really long. You can use it to, let's see, if we cat this JSON, I'm dumb. If we cat this JSON and tell back, hey, pretend this is JavaScript real quick, we can then get that JSON syntax highlighted if we chose not to use JQ. But this would work if you were downloading, I don't know, shell script or whatever. It's a great way to preview content from standard in if you can infer anything about its structure. But mostly I use it in conjunction with other tools. It combines real well with FCF. I think you saw that. We can look at the definition of this function. So using it with FCF was pretty easy. The preview command is bat, color it even though output's not a TTY, and then I tell it highlight lines, show me these line numbers in this file. Very straightforward. Hexel. You may never need Hexel, but if you need it, you might really need it. Hexel is a hex viewer, but it does better than other ones. Yeah. Words are hard. So we're going to look up the absolute path to my editor, use Hexel to view it, and then have less page through it. Hexel is a lot like the output of XXD or your other favorite CLI hex viewer, except everything's color-coded. ASCII bytes are teal, white space is green. Well, this is all kind of color scheme dependent anyway, so the colors might not be consistent for you, but it's really easy to tell things apart. And I think that it's difficult to estimate the value of that when you're looking at different hex things, because hex all looks the same after a while. Okay. So I've found that the few times I've needed to really dig into binary things, Hexel really helped. The shell has a few UX problems, and I think some of them can be fixed in trivial or not so trivial ways. So let me see if you can relate to this. You're trying to write a shell script. You needed to download some resource like one time, so you downloaded it with your browser. You already had a thing with that name. Maybe it was an old version, whatever. So your browser named it thing parentheses 1 parenthesis extension. And then you had to type it in your shell, but you couldn't type that parenthesis and actually get the thing. You realized, oh wait, I need to escape every parenthesis. Or, God forbid, you created a file with a runaway touch command that has a new line in its name, and you had to figure out how to escape \n. Or any number of the other symbols that actually mean something in the shell. Files with exclamation points in their name. Files with $signs in their name. Unicode that you don't have keys for on your keyboard. So how can you possibly type the file's name? It's hard to deal with this stuff, or at least it was. Detox is a CLI that just renames files to get rid of characters that are really hard to work with in the terminal. And so we can do this, or we can demo this simply by going to my downloads and telling Detox to do a dry run on everything here. So you'll see I have a Windows 10 virtual machine image, and it's removing spaces from that. And I have this XML file with that parentheses problem, and now the parentheses have been converted to hyphens. You can rely on Detox to remove every single thing that you would have had to escape. And sometimes that does mean I wish the lights were still at 2. I liked that. But sometimes that does mean that you're completely removing all international characters. But it makes it a lot easier to manage files in scripts. There's also an inline form of it. So if we were to ls, which is secretly exa, inline detox, all of this, inline detox uses standard in instead of the names of files, and it renames them on the fly. You can see here's that OVA file. Now this syntax doesn't actually give us the nice little arrows to say, hey, I fixed it right here, but it has happened. So detox, I think, is not especially well known, but it saved me so much work. And then there's fish, and this is a big one. Big in the sense that it's like a huge change to your workflow. So I have been using the fish shell this whole presentation, and I totally get it if you're not interested in changing shells. That's fine, right? All these other tools would have worked if you're in a reasonably popular shell. But let me show you the things that I really love about fish, and maybe that'll at least give you some perspective on why I like it as a feedback-focused option. Do I have 5 minutes left?
Yes.
Okay. Well, maybe we should be really fast. Really, really fast. It can parse your man pages and generate completions for every executable you have, regardless of whether anyone has packaged those completions. It can also tell you when executables don't exist, right? It's orange now because that's not a thing, but that is a thing. And it can give me feedback on whether a path exists. The CO indicates that there is a thing that starts with that in this file, but the underline is going away as soon as I start typing characters that don't plausibly match something that exists, right? So this is feedback. This is instant feedback while I'm still typing the command that what I am typing is what I intended. Okay. I can't tell you about all those things. It's just too much. There is a cool tool that lets you run arbitrary commands when files change. It just watches them and does some other shell script whenever a change event occurs. Love it, can't recommend enough. I used it to generate this presentation. Whenever I saved the markdown, the slides re-rendered. It was great. Tmux is cool. Lets you make infinite terminals out of one terminal. You may have heard of it before, though. It kind of looks like this, except when your font is not huge. This is like sane. Well, maybe not that many, but like that might be sane. There's a great editor called Cocoon that I've been using this whole time. It's like Vim, but much richer feedback. I would encourage you to go read about it, especially if you're used to a VI-like editor. I think it has a lot to offer. Any questions? Yeah?
How many of these are packaged up in popular Linux distro versus packagable?
Almost all of these tools are going to be available in like recent releases of Ubuntu, of Fedora. Practically everything I mentioned is in Arch. Yeah, if you're on Linux or even in Homebrew, most of these are available. Anything else? You can get my slide deck at the URL here at the bottom. It's hosted on SourceHut, which is cool. You should check that out too. All right, well, if you have cool tools, please reach out. There's a bunch of ways you can contact me, and I want to hear about them. So do it. Thank you so much for coming.